Alright guys, welcome to today's tutorial. Today we'll be looking at IJMB Mathematics past questions. Get your writing materials ready with your calculators. We'll be right back. Given that sec theta equals 25 over 24, compute the value of cot theta plus cos theta. Now, in our trigonometry, we know that sec theta is 1 over cos theta and cot theta is 1 over tan theta. So either ways, we need to find adjacent, hypotenuse, and opposite. So applying our Pythagoras theorem, bearing in mind that sec theta, which we are given, is 1 over 20 cos theta. So this will be 1 over 25 over 24, which will give us, so therefore cos theta would give us 24 over 25. And we know that cos theta is adjacent over hypotenuse. So 24 will be our adjacent and 25 our hypotenuse. So therefore our hypotenuse will be 25 and our adjacent will be 24. So we need to find our x, which is our opposite. In application of Pythagoras theorem that says hypotenuse squared equals opposite squared plus adjacent squared. Our hypotenuse in this case is 25 equals opposite x plus adjacent, which is 24 squared. So 25 squared will give us 625 equals x squared plus 576. So our x squared will be 625 minus 576. So our x squared will give us 49. So x equals root 49, which will give us 7. So our opposite will be 7. Now back to our question. We know that tan theta equals opposite over adjacent. So our opposite is 7 and the adjacent is 24. So for us to get cot theta will be 1 over tan theta equals cot theta. So our cot theta equals 1 over 7 over 24, which will give us 24 over 7 as our cot theta. Okay, now cos theta we already know is 24 over 25. So cot theta plus cos theta would be, cot theta is 24 over 7 plus cos theta, which is 24 over 25. Now, if we do this, our LCM here will be 25 times 7. 25 times 7 will give us 175. So 7 here will give us 24. So this will be 24 times 25 plus 24 times 7. Okay, so 24 times 25 would give us 600 plus 24 times 7 would give us 168 all over 175. So adding these two, we are having 168 plus 600, that will give us 768 over 175. So 768 divided by 175 would give us 4.389, which is approximately 4.4. So our cot theta plus cos theta will give us 4.4. If alpha and beta are the roots of the equation x squared minus 5x plus 6 equals 0, find alpha minus beta. Now, for us to solve this, we factorize this equation. So this will give us 6x squared. So the factors of 6 that will give us 5 will be 2 and 3. Okay? Now, since we are having a minus 5 and a positive 6, this will be minus 2 minus 3. Minus 2 plus minus 3 will give us a minus 5, and a minus 2 times minus 3 will give us a plus 6. So, replacing minus 5 with this, we are going to have x squared minus 2x minus 3x plus 6 equals 0. So, grouping these two together, we are having x is common. So if you remove one x from here, we have x left minus 2, and minus 3 is common. If you remove 3 from here, we have x left. 6 divided by 3 will give us 2 equals 0. So bringing these two together, we have x minus 3 equals 0. So therefore, x equals 3, and x minus 2 equals 0. So therefore, x equals 2. All right, now these are our two factors as alpha and beta. So if we say alpha minus beta, okay, where this is alpha and this is beta, all right, we would have 3 minus 2, which will give us 1. And if we turn it the other way around to score this beta and alpha, having it as alpha and beta here will still give us 2 minus 3, which will give us minus 1. So therefore, we can conclude that our alpha minus beta would be plus or minus 1. Express root 2 plus 3i all over root 2 minus 3i all squared. Sorry, this is an error from the typist, so please, this is our original question. So now in the form of a plus ib. Now, in solving this, we'll first of all multiply this expression with the conjugate of our denominator, which will give us root 2 plus 3i all over root 2 minus 3i times root 2 plus 3i all over root 2 plus 3i. Now, opening up our numerator, root 2 times root 2 will give us 2 plus 2 times root 3i will give us root 2. Okay, will give us 3i root 2. Now, this times this will give us plus 3i root 2. And this times this will give us plus 9i squared. Okay, all over this times this will give us 2. This times this will give us plus 3i root 2. This times this will give us minus 3i root 2. And this times this will give us minus 9i squared. So this will cancel this, leaving us with 2 plus 2 bracket 3i root 2 plus 9i squared. Now, if you open up this, all over 2 minus 9i squared. Now, if we open up this will give us 2 plus 6i root 2 plus 9. Now, in our vector, our I squared is minus 1 all over 2 minus 9 bracket minus 1. Okay, so this we will now have 2 plus 6I root 2 minus 9 all over 2 plus 9. So this will give us 2 minus 9 will give us a minus 7 plus 6I root 2 all over 11. Now, if we put this in form of A plus B, we are having our A to be minus 7 over 11 and our B to be 6I root 2 over 11. But let's not forget that this is supposed to be squared. Okay, so squaring this, we are going to look at A plus BI all squared. Now expanding this, we have A plus BI times A plus BI. So this times this will give us A squared. This times this will give us plus ABI plus ABI plus BI squared. Okay? Now this will give us A squared plus 2ABI plus BI all squared. All right, now replacing our values for A and B with this, we are going to have this as A is minus 7 over 11 squared plus 2 times A minus 7 over 11 times BI, which is 6I root 2 over 11 times, plus 6I root 2 over 11 all squared. Now expanding this will give us 49 over 121 plus 2 times 14, 2 times 7 will give us minus 14. Okay, 2 times minus 7 will give us minus 14 over 121 times 6I root 2 over 11 plus 6 squared will give us 36I squared times 2 over 121. Okay, so this will now give us 49 over 121 plus 6 times 14, 84I root 2 over 121 plus 36 times 2 will give us 72I squared over 121. All right, bearing in mind that our I squared is minus 1, so this becomes 49 over 121 plus 84 I root 2 over 121 minus 72 over 121. Okay, so now we have a common denominator. So our LCM will be 121. This will become 49 minus 72 plus 84 root 2I. Okay, so 49 minus 72 would give us a minus 23 over 121 plus 84 root 2I. So this will be minus 23 over 121 plus 84 root 2 over 121. So our A will be minus 23 over 121 and our B will be 84 root 2I over 121. If the 16th term of an AP is 3 times the 4th term, prove that the 23rd term is 5 times the 3rd term. All right, they said the 16th term is 3 times the 4th term. So we have to prove that the 23rd term is 5 times the third term. All right, now we know that in our general formula for AP, arithmetic progression, we have it as Tn equals A plus n minus 1 D. All right, now in this case, our 16th term, T16, will become A plus 16 minus 1 D, which will be A plus 15D. And our fourth term, T4, would be A plus 4 minus 1D, which will give us A plus 3D. Now, since A plus 15D equals 3 brackets A plus 4D. All right, now this will become A plus 15D equals 3A, plus 3D, 3A plus 9D. Okay, putting all terms to one side, this will give us A minus 3A plus 15D minus 9D. Okay, so this will give us a minus 2A plus 15 minus 9 will give us a 6D. So from here, we can say that our 2A equals 6D. So A equals 6D over 2. A equals 3D. Now, bearing in mind that our A equals 3D, our 23rd term, T23, will give us A plus 22D. And our T3 would give us A plus 2D. But now they said we should prove that A plus 22D equals 5 times A plus 2D. Now, we are going to substitute the value of our A into this equation to see if they will give us same answer. So having this, we are having our A as 3D. So this will give us 3D plus 22D equals 5 brackets 3D plus 2D. So 3D plus 22D will give us 25D, and 5 times 5D will give us 25D. So with this, we've proved that our 23rd term is 5 times our third term. Given that x minus 1 is a factor of the polynomial px squared plus qx plus r, and when the polynomial is divided by x plus 1 and x minus 2 leaves remainders of 2 and 8 respectively, calculate the value of p, q, and r. Now, we know that our fx for our polynomial equals p x squared plus qx plus r. Now, when our x, which is a factor, x minus 1, which is a factor, so we know that x is 1, okay? So when x is 1, for this becomes f1 would give us p1 squared plus q1 plus r equals 0. So this will have as p plus q plus r equals 0. Let's call this equation 1. Now the second part says that when it's divided by x plus 1, we know that our factor here will become minus 1. So f minus 1 equals p minus 1 squared plus q minus 1 plus r. The remainder is what? 2. So this will be equals to. So this will give us p minus q plus r equals 2. Let's call this equation 2. And for the third aspect, it says x minus 2, which gives us x equals 2. So our F2 will become P bracket 2 squared plus Q bracket 2 plus R. Our remainder will be 8. Okay, so this gives us 8, which will give us 2 squared is 4P plus 2Q plus R equals 8. For this equation 3. Now, let's write out our 3 equations and equate any 2 of them. So we have P plus Q plus R equals 0, and P minus Q plus R equals 2. So from here, we can eliminate our P and R, okay, by subtracting equation 1 from equation 2. Subtract equation 1 from equation 2. So we are going to have it as P minus Q plus R equals 2 minus P plus Q plus R equals 0. Now doing this, P minus P will cancel out. Minus times plus will give us a minus. Minus 1 will give us a minus 2Q. Minus times plus minus will cancel out to give us 0. 2 minus 0 will give us 2. So therefore, our Q equals 2 over minus 2, which will give us a minus 1. Now, bearing in mind that our Q is a minus 1, we can now solve out into any of our equations. Okay, let's look at equation 3 or 2. We are having our P minus Q plus R equals 2. Okay, and substituting for Q here, we are having it as P minus 1 plus R equals 2. So this will give us P plus R equals 2 plus 1, which will give us 3. So we know that P plus R will give us 3. All right, bear in mind that our Q equals minus 1. All right, substituting Q into this, we are having 4P plus 2 bracket minus 1 plus R equals 8. This will give us 4P minus 2 plus R equals 8. So 4P plus R equals 8 plus 2. 4P plus R equals 10. Let's call this equation 4. And substituting into our equation 1, where we have P plus Q, okay, in this term, minus 1 plus R equals 0. This will give us P plus R equals 1, equation 5. So now, bringing our equation 4 and 5 together, we have 4P plus R equals 10 and P plus R equals 1. So we can now subtract, all right? Now, 4P minus P will give us 3P, R will disappear, giving us 10 minus 1, 9. So our P equals 9 over 3, which will give us 3. Now, knowing what our P is, that our P equals 3, we can now find our R. So our P plus R equals 1. So R equals 1 minus 3, which will give us R equals minus 2. So P equals 3, R equals minus 2, and Q equals minus 1. Obtain the first 4 terms of the binomial expansion of x minus y raised to the power 10 and use it to estimate the value of 0.9 raised to the power 10, correct to 3 decimal points. All right, now in expanding this, we are going to have our x raised to the power 10 plus 10x raised to the power 9 y raised to the power 1 plus 45 x raised to power 8 y raised to power 2 plus 120 x raised to power 7 y raised to power 3, and so on and so forth. So since you're interested in the first four binomial terms, 1, 2, 3, 4, these are our first four binomial terms. Now, they say we should use this to evaluate or estimate 0.99 raised to power 10. And we know that 0.99, for us to get 0.99, we can rewrite it as 1 minus 0.01 raised to power 10. Sorry, this would be a minus x raised to power 10 minus this, and this also a minus. So let's be careful with our signs. Now, coming back to this, our x is 1 and our y will be 0.01. Now, imputing those values into this will become 1 raised to power 10 minus 10 raised to power 1, 10 times 1 raised to power 9 times 0.01 plus 45 raised to power 45 1 raised to power 8 times 0.01 raised to power 2 minus 120 times 1 raised to power 7 times 0.01 raised to power 3. All right, now 10 raised to power 1 will give us 1 minus 10 times 0.01 plus 45 times 0.01 squared will give us 0.01001 minus 120 times, this will be 0.01 raised to power 3. That will be times 0.0000 1, 2, 3, 4, 5, 6. All right. So expanding this will be 10 times 0.01 would give us a 1 minus 0.1 plus 45 times 0.0001 will give us a 0.0045 minus 120 times 0.00001 would give us a 0.00012. Okay, now solving this, we are having 1 minus 0.1 plus 0.123 plus, okay, minus 0.00012 will give us a 0.90438. All right, since they said correct to 3 decimal points, this will become 0.904. So our 3 decimal points. Prove that 2 raised to power 4n minus 1 is always divisible by 5. Now, this can be said to be a mode 5, since we're talking about this being divided by 5. So if we have this, we can now rewrite this as 2 raised to power 4n 1 mode 5. Okay, so that means for every value of 2 raised to power 4, we are going to have a remainder of 1. Now, looking at this, if we 2 raised to power 4 will give us 16 2 times 2, 4, 4 times 2, 8, 8 times 2, 16. So 16 raised to the power n equals 1 mod 5. Now, if we divide 16 by 5, we are going to have, it will divide it 3 times, remainder 1. So we can see that at the end of the day, we are having 16 raised to the power n, or let's say 2 raised to the power 4n minus 1, okay, is always being divisible by 5. Because whatever we raise this power to, this n 2, okay, will still be divisible by 5, and we'll still have a remainder of 1 to rate. All right, so from here, 16n is equivalent to 1 raised to the power n, which is 1 mod 5. Okay, so equating this, we have 16 equals 1 minus our 1, which will give us a 0 mod 5. So now this goes ahead to prove that for whatever value of this we have of 2 raised to the power 4n minus 1 will be divisible by 5. So any of our values of this can be divisible in mod 5. Now, solve the following simultaneous linear equation using Cramer's rule. We have x plus 2y plus 2z equals 1. And we have x minus 3y plus 8z equals 6. And 2x minus 3y plus z equals minus 2. Now, we are going to put this into matrix form. Okay, now we're having 1 plus 2 plus 2, and this is 1 minus 3 plus 8, 2 minus 3 plus 1. So we're having x, y, and z equals 1, 6, and 2. Now, our Cramer's rules talks of x equals delta x over delta, y equals delta y over delta, and z equals delta z over delta. All right, where our delta is the determinant of our matrix, where our delta equals determinant of matrix. Now, to find the determinant of our matrix, we have 1. Okay, this is a 3 by 3 matrix, so we have 1 times minus 3 times 1 minus 8 times minus 3. So we keep this constant and do the factor of this 2. So when we keep this constant, minus 2 bracket 1 times 1 minus 8 times 2. Okay, and when we keep this constant, plus 2 bracket 1 times minus 3 minus 1 times minus 3 minus minus 3 times 2. So this gives us 1 times minus 3 plus 24 and minus 2, 1 minus 16 plus minus 2 times minus 3 minus 6, okay, plus 6. So this will give us 1 brackets 1 times 3 minus 24 will give us 21 minus 2 plus times 15. Okay, minus 2 times 15. Minus 2 times 15. Minus 2 minus 15 will give us minus plus 30. And this will give us 2 times 6. 2 times 3 will give us this should be minus 15 plus 30. This is 3 plus 6. 3 times 2, 6. So this will give us what? 21 plus 30 is 51 plus 6 is 57. So from here, our determinant delta is 57. Now, going forward, to solve for our delta x, y, and z, now for this first column, we'll replace with this. So this will become, our new matrix for delta zx will become 1, 6, 2, 2 minus 3, and 2, 8, 1. So we'll find the determinant of this matrix. Okay, now, same way we did this, we are going to solve for the determinants of this. So this becomes 1 bracket minus 3 times 1 minus 8 times 3 minus 3 minus 2 bracket 6 times 1 minus 8 times 2 plus 2 bracket 6 times minus 3 minus 3 times 2. Okay, opening up, we have 1 bracket minus 3 minus 24. Okay, minus times minus plus 24 minus 2 bracket 6 minus 8 times 2, 16 plus 2 bracket minus 18 plus 6. Okay, this will give us 21. 1 times 21 minus 2 times 10, which will give us plus 20. So this will give us a minus 10 here, and this will give us a minus 12. Okay, so this will give us minus 12 times this will give us minus 24. Okay, this will have 21 plus 20 minus 24, which will give us 41 minus 24. 41 minus 24 will give us 17. So our delta x equals 17. Now, to calculate delta y, we change our second column with our constants. Okay, so this is going to become delta y equals 1, 1, 2, 1, 6, 2, and 2, 8, 1. Now, we'll now find the matrix of this determinant. Now, to do that, our 1 will be constant. 1, 6 minus 6 times 1 minus 8 times 2. All right? Now, 1 is constant minus 1. 1 times 1 minus 8 times 2. 2 is constant plus 2. So this becomes 1 times 2 minus 6 times 2. Okay? Now, this will give us 1 bracket 6 minus 8 times 2, 16. minus 1 bracket 1 minus 8 times 2, 16, plus 2 bracket 2 minus 2 times 6, 12. Okay, so this will give us a minus 10, a minus 10, sorry, a minus 15, and a minus 10. So 1 times minus 10 will give us minus 10. Minus times minus will give us plus 15. Minus times plus will give us minus 10. So calculating this, we are having minus 10 plus 15 minus 10. That will give us a minus 5. So our delta y will give us a minus 5. For delta z, we'll not change our last column to our constant. This becomes 1, 1, 2, 2 minus 3, and 1, 6, 2. All right, now we'll find the determinant of this. This becomes, keeping one constant, minus 3 times 2 minus 6 times minus 3 minus, keeping 2 constant, 1 and 2, 1 times 2 minus 6 times 2 plus, keeping 1 constant, 1 bracket 1 times minus 3 minus 3 times 2. So if we do this, it becomes 1 bracket minus 3 minus, okay, 6 times 3, 18, minus minus plus 18, minus 2 bracket 2 minus 6 times 2, 12, plus 1 bracket minus 3, 6 times 2 times 3, 6, minus minus plus 6. So minus 3 plus 18 will give us 15. Minus 2 minus 12 will give us minus 10. And minus 3 plus 6 will give us 3. So now, opening this, 15 times 1 will give us 15. Minus times minus will turn to plus. 2 times 10, 20. Plus 2 times 3 times 1, 3. Which will now give us 15 plus 20 is 35, plus 3, which will give us 38. Now, coming back to our Cramer's rule, which says that x equals delta x over delta, which is, our delta x is 17 over 57. Y equals delta y over delta. Our delta y is minus 5 over 57. And our delta z, our z equals delta z over delta, which will give us 38 over 57. So our x is 17 over 57, and our y is minus 5 over 57, and our z is 38 over 57. With this, we've come to the end of today's tutorials. Don't forget to subscribe, like, and click on your notification button for more updates.